Hello, my name is Roman. You probably know me as a big cube blind solver, and this video is going to be a tutorial on how to solve 6 plus BOD, which stays for solving a 6x6 and bigger cubes blindfolded. I am apologizing for the way I speak English, because this is not my native language and this is definitely not the best language that I speak, okay? So there are not so many people who succeed in 6 plus blind, and here's why. So, first, people think that this is ridiculously hard, and it looks ridiculously hard, when actually it's not. It's not as hard as it looks like, okay? But the reason why I am involved in blind solves is because it looks hard and it makes me look like a genius, when actually I'm not. Okay, second thing. 6 plus are unofficial events. Despite that, I put a bunch of effort to succeed in 7 blind, 8 blind, etc. just because I found this is the big accomplishment for me to solve those cubes blindfolded, and because not so many people can do it, when actually everyone can do it. And here's what to start with. So obviously you should know how to solve 3 blind, and if you don't, then I highly recommend you to learn 3x3 blindfolded, because it can take like 1 or 2 days to learn it. It's not so hard, but it looks really like when people who don't know about speed cubing, and when those people look how person solves like the Rubik's Cube blindfolded, it looks like mind-blowing. So this is the very useful skill to show like a party trick or anything. And if you do not know how to solve 4x4 or 5x5 blind, which are official events on WCA, then I recommend you to learn, to watch Cory Strakov's video. He made an awesome tutorial on 4 blind and 5 blind. You can learn 4 blinds in like 2 days. It took a bunch of practicing, like writing down the information that you should memorize and executing it while not blindfolded. And after a couple of days of learning it, you can just try to solve it blindfolded, and you will find that this is not so hard. And if you know how to 5 blinds, you can watch my video to learn how to 6 blinds and bigger cubes blindfolded. So there you go. Alright, before I'll move to 6x6 and bigger cubes, I need to say something very important in addition to Cory's video, which is related with memorization wings on a 4x4 or bigger cubes. Wings are those pieces, so edges on a 4x4. I will keep my cube in orientation so that green is front and white is up layer, because I believe this is the most popular orientation out of blindfolded solvers. So in R2 method, the buffer is df small r, which means out of df wings, we use this. To start memorization, you look at the buffer. So now, in our case, white orange piece is here, and you need to understand where does this piece go. Out of white orange wings, to here or to here. What Cory suggests is something that's called tracing or tracking. You imagine this piece goes something to here by rotating layers on the cube. So we can bring white orange piece something to here by doing d prime L2, which brings our piece that was in buffer, sorry for my English, to UL small b, to here, not to here. That means buffer piece should go there and not there. What I suggest to do, because I found tracing something that is very hard and inefficient, what I suggest to do is first rotating the cube so that white layer is down layer and orange is front, like this. So we have again white orange piece in buffer. We rotate the cube so that white is down and orange is front. And since our buffer position is df small r, we need to shoot this piece in this position, which now is df small r. So to here. Now we rotate the cube back, holding the finger there, and realize that the buffer should go there and not there. Now we remembered this position and the orange white is there, so to realize where should it go, we rotate the cube so that orange is down layer and white is top, like that. So this piece obviously should go to there, but how to understand this is rotating the cube like this, and now the piece should be shooted. Now the piece should go to D, F, small r, right there. So eventually we memorized that from buffer piece goes to there, then goes to there. Let's check it by solving this cube with the R2 method. So for this piece, the algorithm is like that, and for this piece I'll show a few more examples. In this case we have red blue piece in buffer. Look at the red blue wings, and to realize where should it go, red blue, rotate the cube so the red face is now down and blue is front, like this. No, like that. So red blue, the piece should go in D, F, small r, right there. And that is how you understand that this piece should go there and not there. I think that makes sense. It's just something that I found more easy than tracing, so I guess that might help you. Now to the 6x6. First thing you need to ask yourself is what types of pieces there are on a 6x6 cube. My cube is a bit broken, but good enough for demonstration. Like in 3x3, there are 8 corners. Also, like in 4x4, there are wings, but there are 2 groups of them. So wings from one group will never replaced with wing of the other group. Even if you'll physically remove this piece and will try to insert into this position, you'll have trouble. There are also 2 types of extenders. One type is inner extenders, there, 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 and there, and another is outer extenders, which located on corners of the square. So it's very easy to understand where extenders are. They just forms the letter X on each face. All other center pieces are oblique-wise, so they're located there, there, so all around. And so this is all the pieces that you need to solve. Second thing you need to know is how to distinguish between 2 groups of oblique-wise on a 6x6. So on this cube there are 2 types of them. They are not interchangeable like extenders, 2 groups of extenders. So even though those 2 pieces looks pretty much the same, even if you'll remove it and look at it, they belongs to different groups of oblique-wise, and consequently they can be swapped even physically or with algorithm. So if I'll ask you, for instance, can this piece right here be moved to this position? Like this case it's obvious because this piece can be moved to this position by doing small l, but if you go to some more complicated examples, like is this piece interchangeable with this one right here, it becomes more hard to determine by doing dragging. So really the answer is if those pieces, this and this, belongs to one group of oblique-wise, they are interchangeable. If they belong to different groups, they are not. As I said, there are 2 groups of oblique-wise. Here what I did is I draw the location of oblique-wise pieces on the side of 6x6 cube. So this circle corresponding to this piece, here to here, etc. So first thing you need to do is imagine the cross on the side of the cube, like this. So we'll divide the side of the cube into 4 pieces, into 4 quarters. On each quarter there is 2 obliques, and first thing that I'll tell to you is on each quarter 2 obliques belongs to different groups. Secondly, you need to imagine the clock hands parallel to the line of the cross. So you imagine the clock hands, and you imagine it goes actually clockwise, and the piece that it meets first, like that, belongs to first group of obliques, and the piece that it meets second belongs to second group. It's very simple. Again, it starts moving right here, and it like crosses this piece first, so it's first type, first group, and it meets this piece in this quarter second, it's the second group. Then we cross this line and we move to next quarter, and the clock hand meets this piece on the next quarter first, so it's the first group, and this piece second, so it's the second group. We can keep that on and mark those pieces as well. First, second, first, second. You can tell this also by those 2 pieces can be swapped by doing U move, so moving U layer like this, as well as those 2, or those 2 pieces can be swapped by doing U2. Here what I did on a 7x7 is I highlighted on the yellow side one group of obliques by red color and another by white color. Now, using this technique, you can easily say which color represents which group. So imagine the cross like this. Then imagine the clock hand, go clockwise, and you see it meets red piece in this quarter first, like that, and white piece second. So in this quarter red piece belongs to first group and white to second. Then you move to here and keep on. So again, red piece first and white piece second. And this is how you distinguish between 2 groups of obliques. Now I will explain you the U2 method for solving obliques. As been said, you need to be familiar with U2 method for solving extenders on a 4x4. If you don't, then watch Corey's video. He made an awesome tutorial on B-cubes blind, and he explains U2 method for this buffer in extenders, so U, B, R. If you are familiar with U2 method but your buffer position for extenders is this or another, then you can still watch the video, but you'll need to do either 2 things. You can watch the entire video to understand the conception for solving obliques by U2 method, and then adapt all algorithms or set of moves for your buffer or buffers. Or you can switch to this buffer position for a while, at least for solving obliques. Why this is important? Because solving obliques on a big cubes is exactly the same process as solving extenders on a 4x4. The only difference is you need to understand what layer you need to rotate. Like, for instance, if algorithm says that you need to do small r move, then here you need to be concerned what layer actually you need to rotate, this r or this r. Now I will quickly show you that for solving obliques you should apply same setup moves and algorithms as for solving extenders. Here what I have is orange piece in buffer. We should go there. So setup moves for this piece, for bringing it to this position, would be L, small d, L prime. Then you do U2 and undoing setup moves. L, small d prime, L prime. Same here. L, small d, small L prime. U2, small L, small d prime, small L prime. As you see, they are in the same state. Now, for the green piece and the front face of the cube, Y rotation, then those setup moves, U2, and undoing. And same here. Y rotation, then setup moves, U2, undoing. So basically to be able to solve oblique-wise, you need to know three things. First thing is where actually buffer piece is located for each group of oblique-wise. You don't need to constantly determine it by any techniques or using this clock hand stuff. You just need to remember it, just to know it. So just learn it once that the buffer piece for the first group of oblique-wise located there, so more far from you and more close to the middle layer, right here. And for the second group, it located here, so more far from the middle layer and more close to you. This is important to execute the algorithms for U layer, for this and this piece. Second thing is the most important. You need to understand and you need to know where helper positions located. You'll not have a time for determining them by clock hand, trick, or any other method. You just need to know it, right? So for the first group of oblique-wise, helper position is this. So closest to you and closest to the middle layer. And for the second group of oblique-wise is farthest from you and farthest from the middle layer, so right there. This is important to apply in setup moves for solving pieces on the sides of the cube and also on the bottom layer. Third thing is the rule that will make you understand what inner layer you need to rotate. So something that I was talking about a minute ago. The rule is very simple. So now let's for example, our algorithm starts from this move. I'll explain why in a minute, but let's just for example do this. So it starts with moving this layer, which is closest to the middle layer, and the rule is very simple. In a part of algorithm in setup moves sequence, two adjacent moves of inner layer are different, meaning that if we moved this layer first and now we need to move some down layer, this or this, then we remember that now we move this layer, which is closer to middle layer, and so then we need to move a layer which is more far from it, so this layer, down layer, not there. Alright, so we move this layer. I'll call this layer inner layer and this outer layer. So after moving inner layer, we need to move outer layer. And after moving outer layer, we need to again move inner layer. So they're kinda alternating, moving inner and outer layers. Alright, so in this case, we need to execute the algorithm for this piece. Alright, first we need to move helper position down to here, doing L layer. Now, how to understand if we should move this layer or this layer? As we are solving first group of oblique-wise, if you remember I talked a minute ago about this is important to realize where our helper position is, and it's there. It's closest to the middle layer. So we need to rotate this L layer, which is closest to the middle layer, because we need to move our helper position, which is this, for the first group of oblique down here. And now we remember the rule that I talked about just now. We need to do D move, then L prime move. We just did inner layer rotation, which is closest to the middle layer. So now we need to move D layer, which is more far from it. So not this, but this. And after that, we again need to move this layer. Then do U2. And same thing for undoing setup moves. You bring helper position there, then D prime, L prime. Same here, bring helper position here. Then remember that you just moved this layer, which is closest to the middle. So now you need to move layer which is farthest from it. So not this down layer, but this. And you just moved the layer which is farthest, so that means you now need to move the layer which is closest. I hope that makes sense. And now let's move on to some example solves. You know, I hate doing example solves because they took so much time and they are very boring to watch, but this is just for you to better understand how U2 method for oblique works. So, alright, let's begin. Here what I did is I scrambled extenders on this cube as I scrambled first group of oblique in 7x7. So as you see, green piece on this buffer, green, orange, blue, and there green, orange, blue as well. So, and I scrambled extenders on this cube as I scrambled oblique of the second group in 7x7. So let's start solving it by solving first group of oblique. Alright, green piece, and the only green center unsolved on the green side. For solving it, we do setup moves that brings this piece to here without disturbing the U layer, which is little L prime, little U2, little L. Here what we need to do is same moves, but with a we need to think what L layer we need to move first. And we remember that our helper position for first group is here. So the first motion would be moving our helper position to here. That means that you need to move inner layer. I will call this layer inner layer and this outer layer on each side as well. So inner layer, outer. Okay, so moving little L prime, inner layer, and remember our third rule. I will call it like that. Third rule. So after we moved inner layer, you move outer layer. So U2 would be this U2, and then inner layer again, L. Then do U2 and undoing those setup moves, and here as well. U2, and again bring our helper position to here, then U2, and move it back. So now I have white piece in buffer, and let's just move it to here by doing this the most simple algorithm in U2 method, which is U2. Now blue piece. Let's look at the blue face. There is the only piece unsolved, which is B, U, L. Now we cannot just apply setup moves bringing this piece down to here by doing little L prime, because it will move this piece to the down layer, which is not good. We first need to get this out of the way like this, doing little U prime, and then apply the setup moves for this piece. So 1, 2, 3. Same here, we need to remove this piece out of the way, and for that for doing this we just need to realize what U layer we need to rotate. That might seem a bit tough, but here is how you do it. So remember the third rule. You know that after doing some of U layer moves, you will do inner L prime. And because moves are alternating, inner and outer layer, then before moving inner layer, you need to move outer layer. So this is why you do outer little u prime. Then apply setup moves for this piece. So little l prime, ul. Then do u2 and undoing all those setup moves. u2, again, move this piece to here, out of the way, return back, and back. Okay, now we have a yellow piece, which is on the bottom layer, and I will use the same algorithm for D layer as was suggested in Corey's video. So first move it to here, D, which brings our target piece into D, B, L position, and do algorithm. Let me remember. Alright. L, E2, D2, B2, L prime. Okay. Then do U2 and undoing this algorithm. Yeah, that works. And undo the first setup move. Now we need to do same things here. So bring this piece to here and do an algorithm for this. But the first move is L, and again we need to understand what L layer we need to rotate. So you just need to understand what actually this algorithm do. So it obviously brings this piece to this position, and to do it you need to first move your helper position to here. So again you do inner L layer move, then do B2, and then you need to do D2 this or this. Again, remember third rule, after you did L layer, which is inner L, you do outer layer rotation. B2, L prime, U2, and undoing all those moves. L, B2, D2, L prime, no, B2, L prime. Sorry, I just didn't solve for a couple of years by U2 method. And bring this piece back to here, so D prime. Now we have white piece in a buffer, so we need to apply the algorithm that brings this piece to here, since this is the only unsolved piece on the top layer. Again, we can do the algorithm that was suggested in Corey's video, which is this. Same thing here. You first need to understand what actually algorithms do to understand what layer you need to rotate. So first three moves, bring this piece to here, which means that you need to first bring this piece down to here. And since our piece in the first group of oblique Y's located here, then you need to apply inner L layer, inner R layer move. And according to our third rule again, you need to do outer U move and inner R move again. So then you do U prime and keep on like you did it previously. Now, orange piece is, I believe, the last, yeah, which is here. So right there. For this piece, setup moves are Y, then L, U2, L prime. And here, Y, then you do L move, but you do that L which brings this piece to here. So we should disturb this piece. It means we do outer layer move. Then according to the third rule we do inner layer move, U2, and outer layer again. Then U2 and undoing setup moves. U2 and again bring this piece here. Move inner layer, move outer layer. And now we solved first group of oblique-wise. Now to the second group. So we have this buffer position, orange piece here and orange piece here. And we need to move it to here, which is the only unsolved position. So again, L, D, L prime, U2, L, D, L prime. And there we need to remember where our helper position is, right there. We move it to this position by doing L move, outer L move. So after that we need to do D layer, so D move, we need inner layer to move and bring this piece back to here. Do U2 and doing the setup moves. Now red piece, which is located right here, we can't just apply little f move because it will disturb this piece. So we need to first move it somewhere to here, for instance. Then do setup move for this piece, U2, and doing all setup moves. And for red piece, which is located here, we need to bring this piece to here. Obviously, when your eyes will be closed, you will not see that this piece located here. So you'll need to determine. Obviously, when your eyes will be closed, you will not see this piece, and you will not know that it's located right here. So again, you will need to determine where this piece is in order to move the right layer. So you can do it even according to clock hand technique. So to determine which of those two pieces you need to solve, you know that now you are solving second group, so imagine clock hands going clockwise, and it means this piece second. So this is the piece that we need to solve. And you imagine it and you know that it's on the U layer, which is here. So you do outer U layer rotation. Hope that makes sense. So after that, move helper position to here and bring this piece back. U2, undoing setups. Now white piece. According to my system of solving, order of solving pieces on each center, the first piece I will need to solve is this. So let's do algorithm for this. Again, the first move is R prime, and obviously in 4x4 it would be this, and on the 7x7 it will be this, like the R move which brings this piece to here, our buffer piece. It means we need to move outer layer. Alright, so for UBL move, let's do algorithm R prime U R U R prime U prime R U. All algorithms would be in the description. And for this, bring this piece down, so outer layer, then inner layer, outer again, U, and repeat all this stuff. Bring it back, do U move again, then bring it again to here, U2, then bring it back to here, and do U2 move again. That's how the algorithm works. So now the blue piece, which is there, so simply move this piece, which is BDL, to our helper position by doing this, U2, and undoing. This is how you solve it as it was external, and the same as it was oblique Y. Move it here, and then do U2 and undoing setup moves. No, sorry. Okay, yellow piece now is in the buffer, which is down piece. We'll move this to here, then apply an algorithm, L, B2, U2, B2, L prime, then do U2 and undoing those setup moves. And then bring this piece back to here. And there, after moving this piece to here, we need to first bring our helper position to here by doing L move. So we do outer L move, then keep on doing algorithm, then D2 would be obviously inner layer move, because previously we did outer layer. Then keep on doing algorithm, do a U2, and undoing those setup moves. Yeah, I'm a little bit stuck on it. So bring this piece back to here. So now the white piece is in the buffer, but during memorization we'll memorize that we need to shoot this piece to this position now. But notice that we did uneven odd number of U2 moves. So now we have those two pieces swapped. It means we need to apply the algorithm for this piece again. So UBL. All right. And same thing here. First, bring this piece to here. Then U, and keep on. Now green piece. Alright, that was weird. So green center is in the buffer. We need to shoot it here. So regular algorithm. U2. Same thing here. Bring this piece to here. So we need to move our helper position, which is located on this layer. That's why we do inner F at the first. Then U prime. Now again, white piece. We can move it here. And the last green center, which is located right here. Again, we need to move it out of the way, then apply setup for this piece, U2, and undo all setups. Now, so this is how you do it. Move this piece out of the way right here. Again, to determine which D layer you need to rotate, you can just find this piece according to clock hand rule. So you know that you memorized FLD. It means that you need to shoot to some of those two pieces, and now you need to understand what piece you need to shoot actually, this or this. So remember the clock hand rule, and you go clockwise and you meet this center first and this center second. Then you remember that you are now solving second group of oblique-wise. It means the center you need to shoot now is this, which is located on inner D layer. So you move inner D layer, then apply setup moves for this piece. So move our helper position here to here. Again, inner D layer, U2, undoing setups. And now we have a parity which can be solved exactly the same as X centers parity. U2. I hope that wasn't that long, and don't blame on me for my weird English. I try to do my best. Now a couple words about memorization. Let's suppose you chose this orientation for the 4x4, like green in this side, white in this side, and orange in this side. So you look at the buffer, it's orange piece right here, and you know that you need to shoot it there. L, D, B. Now, as for the first group of oblique-wise on the 7x7, you look at the buffer, again, clockwise, you know that the buffer located right here. So it's orange in our case. You need to shoot it somewhere there. And the problem that many newbies faced is what center you need to memorize out of those. So yellow center or the blue one. Again, it can be solved with applying clock hand rule. So you divide the face of the cube into quarters, and the clock hand meets this yellow center first and this blue center second. As you are memorizing first group of oblique-wise, you need to memorize the one that clock hand meets first. It means you memorize this yellow center, and after that you keep on memorization. For instance, on that face, yellow face, one of those pieces, again you memorize this because the clock hand would meet this piece first. So yellow piece here, green center here, and move to there. Again, memorize this piece, not this. Hopefully that makes sense. In the second group it will be completely opposite. So orange, you memorize this blue face right here. After that, move into the blue side, which is back, and memorize this red center. Okay, I hope it's completely understandable. Another problem that many cubers face at the beginning is how to find layers while blindfolded. I don't think it's a big problem, but I can give you a couple tips on it. So obviously the most easy layer to find is this outer layer. So if you can solve 7x7 with your eyes open, then I'm assuming you are doing PLL algorithms and easily do it just with outer layers. And you can easily find them while blindfolded as well. So next easy layer to find is this. So actually next to the outer. What I do, for instance, if I want to do a D2 move with this layer, I just find this like border by the tip of my thumb, and this is like I'm grabbing two down layers, and do DW2 move. Then I release my finger from it and grab only down layer and rotate it back. Same thing for the L2 move. Like you can move L2, then find the corner of this piece by the tip of your middle finger and bring it and move it back like that. Alright. Also, middle layer is very easy to find, like you do it on a 5x5, just imaginary dividing the cube into two halves, and this is where the middle layer is located. Like if I want to do E2 move, I just rotate my cube and like find approximately the middle of the cube, and this is where the middle layer is located. And the only layer left is this, and this is just to get used to it. Really, it's just closing your eyes and try to make those moves or Z moves. On the 9x9, same thing can be said about outer layers. And next to outer, I just do like grabbing two layers, do D2 move with them, then leaving my fingers only on D layer and move it back, then find the border, this border by the tip of my thumb, and move those two layers up and return the only R layer back. So this is how you do it. Same thing for the middle layer. Just divide the cube into two halves, and this is approximately where middle layer is located. You can feel if you divided it right into halves, just like, I don't know, trying to figure out if those two parts of the cube are equal or not while blindfolded. This is something that I do while I solve 9x9 blind. Next to the middle layer is this, and this is also something that you need to get used to it if you need to find it blindfolded. Just closing your eyes and trying to do this move. Alright? Like that. The hardest layer to find on the 9x9 is this. So to do, like for instance, R2 move with this layer, I do this. I found that the border between outer layer and this layer by the tip of my thumb. Then I grab those two layers and do R2 prime, like RW2 prime move. Then with the tip of my ring finger I found the corner of this piece and I grab it, and this is how I do L2 move. Like that. Almost the same for D2 or R2, whatever. So that's not a big deal. So finally, what you need to do to solve 6x6 blindfolded? First you need to memorize it. Just memorize first set of extenders as you do it on a 4x4, but only look at inner layers. Alright? Same thing for outer set of extenders. You memorize it exactly as you do it on a 4x4, but looking only at those pieces on each face. Same thing for wings, just memorize them separately, and during execution you execute them exactly the same as wings on a 4x4, but you need to be concerned of what R layer you should do if you solve with R2 method. So for inner set of wings you obviously need to do this R2. Oops, broken cube. And for this set, another R layer. So this is very obvious. And what about execution oblique-wise? This is something that I've been talking about for a while, so I don't see any obstacles for you to now try the 6x6 blind. last thing I want to talk about is oblique-wise on 8x8 and 9x9 cubes. They have similar sets of oblique-wise, so I will use 8x8 for the demonstration. So let's return to 7x7. As I said, there are two groups of oblique-wise, but they are kinda symmetrical because this piece is located on second layer from the top and third layer from the right, and this layer is located third from the top and second from the right. As you remember, 7x7 contains two groups of oblique-wise, and I can say it's two symmetrical groups because look at the pieces. They are located, one piece located on second layer from the top and third from the right. And it's completely opposite for this. Third from the top and second from the right. So we can say that 7x7 contain one class that contains two symmetrical groups of oblique-wise. And for the 8x8, there are three classes of oblique-wise. Each of them contains two symmetrical groups. Here I highlighted one group. So for this piece, second from the top and fourth from the right, and for this piece, fourth from the top and second from the right. So you need to remember buffer positions and helper positions for each group of oblique-wise. So for this, it's like next to the middle layer, and for this, next to this middle layer, like on the 9x9 will be middle layer in between them. So just keep in mind that they are located there, and that's it. Here, second class of oblique-wise highlighted. So this piece straight after this buffer of first class, and this piece straight before this. So again, you just need to remember their locations and the locations of helper positions. To execute algorithms or set of moves, you just need to again bring this piece somewhere when it should go by doing this move. If you're executing this like first group of second class of oblique-wise, then after you did inner layer rotation, you need to do outer layer. Again, you can track pieces just all around the cube to understand what layers you need to rotate. This is my least favorite class of oblique-wise because for the execution you need to perform the most uncomfortable layers rotation, which is this layer and this layer. This piece is located, so the buffer for the first group of third class, located third from the top and fourth from the right. It's opposite for this piece, fourth from the top and third from the right. And helper positions for those two pieces are here and here. So let's just, for example, execute an algorithm for this piece to bring it to here. So move this piece down here, D2, then the algorithm. Do L move first, so bring this helper position down, so like that. Then B2, then D2. After you did inner layer rotation, you need to do outer layer rotation, which is in this case third from the border, like third from the down, this. B2 L prime, then do U2 and undo all this stuff. b2, l prime. Bring this piece down and solve the parity. So just practice it solving the cube while not blindfolded, just writing down the letters for memorizing oblickwise and try to execute them and fix the mistakes straight. That's what I did when I first time tried to solve 9 by 9. Okay, so that was the explanation of how to solve 6 plus BLD. I hope you guys practice it, enjoy it, and have a good time. Goodbye.